Hello everyone. Today we're going to be solving Leetcode Problem 53. It's called maximum subarray. Let's go ahead and read the problem. We are given an integer array nums and we want to find the subarray with the largest sum and then return it. So in this example here, you can see that the largest sum is right here. It's this one, and the output is 6. And we also have this edge case where we have just one number and then we return that because that's the most that we can get from it. So let's go ahead and jump over to the paper where we're going to see some ideas of how we can implement it, and then we'll go back and code it up. All right, well, you can see that I've already got the example from Leetcode written right here. And initially, what someone might think to do is to just check all the possible partitions of the array such that we get subarrays and calculate the sums of each of them and then compare all the possible values that we have. But while this works, it's very inefficient and the running time is exponential. It's going to be very slow for us to do. So instead, we're going to use this idea that's very common in interview questions called dynamic programming. And what we're going to do is we're going to initialize a new array. We're going to call it DP for dynamic programming, the same size as nums. And then for each index I, you see it right here, that's between 1 and the length of the original array. We're going to say that the value at the index is equal to either dp at I minus 1 plus the current index that we're on at nums, or just nums at I. And the reason that this logic makes sense is essentially what we're doing is we're checking, hey, is it better for us to continue the subarray that we're currently on, or are we better off starting a new sort of subarray and then continuing from there? And it might be kind of hard to visualize this if this is the first time you're seeing dynamic programming, but you kind of just need to trust that the math and logic works out. It's a bit like a recursion where you have to trust that the recursion will do its thing. And then lastly, we're just going to return the maximum from the dynamic programming. Whatever index has the highest value, we're going to return the value in that index. And it's also important to note that we need to initialize the dynamic programming array at 0 to be equal to nums at 0. And this is because all our answers kind of depend on the previous one to that. And you'll see how I'll code this up, and hopefully it'll start making a little bit more sense as we go through the implementation. So let's go back into Leetcode, and then we're gonna see how it works. All right, so you'll see here I typed out exactly what we said. I initialized this array called dp, and it's the size of num size, and then I declare the value at 0 to be nums at 0, and then I check for each one. I say that dp at index I is equal to the maximum between either the value of the previous index plus the current index at nums, or just nums at I, and that's like what we said, where are we starting a new subarray or are we continuing the last one? And lastly, I return the max from array, and here, because I'm coding this in C, I had to make these two kind of auxiliary functions, just max and return the max from array. That's it, and you can see that, there we go, it returned, it accepted all the tests. Hopefully this approach made sense to you guys. If you have any questions, leave them down below. Hope you guys enjoyed.